Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on model 2, that is the projection of solids. We have worked out majority of the shapes including triangle, square, rectangle, etc. for prisms as well as pyramids. Now let us work out two important and typical solids. One is limiting case of triangular pyramid, that is tetrahedron, and that we will work out now. And one more is hexahedron, that is limiting case of square prism. First let me take this problem, that is a tetrahedron problem. A tetrahedron of 50 mm sides rests on HP with one of its sides, and a face containing the side on HP is inclined at 30 degree to HP. Draw the projections. When I will take two cases, the side on HP is inclined at 45 degree to VP. This is common question, majority of the solids you have. And the side on HP is 20 mm in front of VP. We will discuss that with a model, both the positions, and then start working. Now, let me, before going to the actual positions and projections, this is the tetrahedron. Tetrahedron consists of four equilateral triangles. Okay, see, this is one triangle, this is another triangle. Okay, 1, 2, 3, 4. Okay, so this is nothing but tetrahedron. So we have the one surface, I keep it on the base, this becomes base. Not officially, just for namesake we say this is base. Then these three are lateral surfaces. This is limiting case of triangular pyramid. Suppose that if I give a particular height 50 mm, 60 mm for the same equilateral triangle with center as reference and move up, fix the apex, that becomes triangular pyramid. In this case, height is very particularly fixed in a given procedure. How to fix the height? Okay, now we will discuss that in that length. Now let me go for the positions. So this is first position because he says as a side on HP. The side to be placed on HP is always perpendicular to what? VP. Now the face is inclined means axis also inclined. It is nothing but the pyramids which we have slant face is inclined some degree to HP means the axis also assumes a particular value of inclination. So first position, second position. So if you assume axis, considering this as the base center and this is the axis, then that also inclined. So if this is inclined, then make it perpendicular to HP so that you get the true shape on HP. So unless otherwise it is equilateral triangle. Say I have given the side equal to 50 means equilateral triangle. Next thing is you have to give inclination. Now the question is, normally when you say face, one of the face, we consider this, we always think that this is base. No doubt this is also a face. Either you can give inclination 30 degree to this or this. Normally people take this and work out. Either can take this or this. Now we will work out both. First here we will work this one, and then in computer we will take this also, and how exactly you get the solution you will see. So first position, second position. I am taking here manually work this one. So this is a face containing the side on HP. Number one. Number two, he says the side on HP is 20 mm in front of VP. Assume that this is VP and HP. Case VP HP. Here the side, after giving first position, second position, the side on HP will be turned 90 degree. In front of means it is always parallel. So if no other information is given, always assume that it is the entire side is in front of VP 20 mm. So this is VP 20 mm in front of VP, draw a line, place it on this. That's all. One more position, it is inclined at 45 degree to VP. That's all. This is case 1. This is case 2. That's all. You can take case 2 here also, but case 1 is fixed. Here only you should take, because at 20 mm you cannot accommodate the entire solid and take away from it. First position, second position, third position is case 2. Case 1 is this or this one. can take the edge away from the VP or towards VP. So we'll discuss this at length while working. Now take the top view is actually equilateral triangle. You know how to draw the equilateral triangle. Side is on HP. This must be perpendicular to VP initially. Now let me have A, B, C corners. Then how to get the center or apex here? Here there is no apex like pyramid, all are sides. So if you keep one face on HP, that becomes base and the top one becomes apex. Same thing I am keeping it here for the continuity of the problem to avoid any confusion. I call that as V. Okay, otherwise you can call that as D, but let me call it as V, assuming that this is particularly limiting case of triangular pyramid. Now let me draw two medians and fix this point. Okay, now join all these points here. Okay, this is V and this is O. Next comes project this and get the corresponding points on the ground. Say ABC, face ABC, A dash, B dash, C dash on ground. Okay, A dash, B dash on ground. Now fix the axis line also. What exactly height? Height I don't know. Okay, that means you have to find the height. How to find the height? Suppose that this is the actual line. This is 40 mm line. It is inclined only to what? VP. And corresponding length in the top view is, say this is 40, this is 25. Okay. But if you look from top, this is parallel to VP. Whenever a line is parallel to VP, projection line, the corresponding front view is true length. Okay. So I will sketch this here. Whenever line is parallel, projection line is parallel, say AB, if you have corresponding front view, this is A dash, let me take V only, no problem. Okay, V dash, A dash, V dash, AB is a line. So in this case, AB is parallel to XY. Definitely the projection in front view is true length. So it is very simple to answer. See, this is actual length, this is top view. Now I will project it. What you get? True length you get. This projection length remains same. This is top view, this is front view. So whenever a line is parallel to XY line, definitely the opposite view is true length. So here you see VA. VA is point of interest now, line of interest now. Line joining the apex and or the vertex and the corner, base corner. Okay, now what I have to do? I don't know height. So this is the vertical projector of V. Take A dash as center, draw an arc. This is V dash. What is this length? 40. 40 or radius you take, draw an arc. This gets you the height. This is how you try to obtain the height of the tetrahedron. We cannot take VB as reference and then draw. Okay, 40 mm because this is not parallel. This is inclined to both the planes. VB and VC are inclined to both the planes. The only possibility is this. Suppose that in your given conditions, this parallel stand length is not there. Then you make it parallel and then project. This is a straight line problem concept. Now, I will fix the front view now. This itself is one of the line now, one of the side. See, 40 mm is the side length. You have to take, all sides are equal. So this is 40, this is 40, this is 40, this is also 40, but in top view it's apparent length. That's why you are getting different. Now you see, this is also side, but they are apparent length. Now base. The problem here lies with fixing height. Now if you measure height, you will get some different value. So I say 50 mm, you will get around 41 something, etc. 41 or 42 point something, etc. That depends on the side of the value. So now you take this height, you measure how much if you want. Suppose that this question demands what is the height, then do it. Otherwise not necessary. Now keep this dimensioning. So 50 Okay. Now, this procedure you must keep, arc, etc. Okay, so that you will get idea, and also this 40R, sorry, not 40R, it is side 50 equal to side. Yes. Now, this line is important for us, or this line, but normally we take the lateral face. Take B1, C1 as a reference. This is the edge on HP or side on HP. With respect to this, you have to draw. Now, let me draw 30-degree line. 30-degree line, and take this distance. Take this distance first and mark. Arc method. You complete this figure. Next, take this second line, second length. This one is the 50 mm, one side. Draw arc like this. Then take base side. This is how you keep the geometry. Okay. Now, join these lines. Yes. What is this point? A dash. This one is V dash. This is BC. Identify the axis. For all practical purposes, we take this as triangular pyramid and work out. Okay. So, ABC, assume that is the base. So, here we have O and this. That's all. Now, dark the required figures. Okay, dark required BC on ground. Then get the corresponding top view. So, to get the top view, project all the points, corners of the base first. That's the base, and identify these points. This is A, this one is C, this is B. You will get the apparent shape, very small shape you get. Next comes V. This is V. Join ABC and join this. All corners with apex. Now, identify the visibility lines, visible or invisible, etc. I am here. Assume that this is base. ABC is on the ground earlier. Now, it is tilted up. The angle is here 30-degree, not for the axis, for the one of the face containing the side on HP is inclined at 30-degree to HP. That's what we did. Now let me take this center and keep this as O. Now start naming A, B, C and V. This is O, and identify the visible lines first. So base is not visible. Step number 1 is base is not visible. Then boundary lines are visible. Next step is boundary lines are visible. Keep all the boundary lines visible. That's all. Now, invisible surface is ABC. Out of boundary lines are these. Only one more left, invisible line, that is BC only. Okay. Next comes the crossing line or invisible surface, visible line. That's all. Otherwise, farthest point item from you is BC. BC is not visible. Any number of lines connecting to the line are invisible, but all are boundary lines. These two are boundary, these are also boundary. Then there is no issue, only dark lines. So either you use the farthest item from you method or the key surface method. Both gets you same, but check with boundary lines dark all the time and crossing line bends, etc. That gives you pakka answer or the solution. Now, what about axis. Is there any scope for fixing the axis? No, because OV is already covered by the visible line. Only you can represent O, this is the position of base end, that is ABC center. That's all. Face ABC and corresponding center is O. That's all. This is the second figure top view. Now, what about the third figure top view and front view? It all depends on the case 1, case 2. Let me work case 2 only first. Okay, it's very easy. What you have to do is, as I explained earlier, first position, second position, third position. Assume that this is VP line and keep 20 mm from it in front of it. That's all. First position, second position, third position. So what I do is, I will redraw this figure such that BC is 20 mm in front of it. Okay. So the question must be like this. It must be, the 20 mm must be more than this. If it is within this, it will go beyond XY line. I hope you will get that only. So the dimensions are very important here. Hope that the 20 mm is this. Okay. So first take the locus. Okay, this is locus of BC. On this line only BC line will come. Redraw this. Okay. So while redrawing, you must be very careful in taking the distances. Okay. This is, if you tilt like this, okay, it may go up. Always you should rotate like this. Then only you can accommodate that within 20 mm. That is 20 millimeter you can accommodate. Now keep this in this direction. Okay, this direction, so that C will be here and B is this. Then finally the midpoint of this will be somewhere here. Then draw a line. Then keep this O and A. Then this point B. Join them as per the requirement. That is top view of second figure top view. I am redrawing such that BC is dotted line 20 mm away from the VP. Hoping that this particular gap will be within that. Now this is O, this is V. Draw this. This is visible. Okay. Now get the corresponding front view. Draw the projection lines and get the corresponding front view. So absolutely B dash C dash is very much on XY line because it is on HP. Okay. Now project O and A. Both are on midline, that is central line A dash. This is O dash. What about V? V is here. So this is a typical case. You may get V above it. I don't know. Okay, that all depends. Okay, let me work in computer and see how exactly it works. As per this figure, I am getting. Now definitely with this figure only you can analyze. It is interesting to analyze this type of cases. So ABC, join ABC. This is boundary, always visible. Okay, irrespective of the situation. Now B is this. Okay, now join AV and BV and CV. Okay, now you are here, base is not visible. Interesting thing is, even though base is not visible, all corners are visible. Okay, here I will show you the situation. It's like this. First position, second position, third position. You see, this happens to be the apex, and you can see all the edges of the base ABC and all slant edges which is joining V. Okay, so this is how you get. Suppose that if it is like this, then this surface is visible and the base is completely invisible. That is, two edges are invisible. That you will see on the computer how exactly it works. So this is also one situation. That all depends on the angle. Suppose that if you have a angle, particular angle, you may get this particular situation. This is the way you have to work. Now, what are the visible and invisible lines? Now assume that I have drawn all light lines. How to keep the visible lines? Now you just check the base is away from the observer, base is not visible. Okay. And if you take farthest item from you, that particular, it is utter confusion. See, A is the farthest item from you, right? So now any number of lines joining that particular point are not visible. Since these two are boundary, fine. But what about this? This is actually visible or invisible. That depends. So suppose ABC is not visible, definitely invisible surface, visible line. So this is the solution you have. Okay. Now let me check whether we have done it properly. According to this figure, the base is AB. Where is ABC? ABC is away from you. Yes, ABC is away from you. AB is not visible. Then invisible surface, visible line. This is the solution. So for this particular angle, I have drawn very rough work. If actual angles are taken and worked out, it may be different. That depends. Okay. Now let me check the other case. Number 2 is the side on HP is inclined at 45 degree to VP. So let me continue here only. Assume that first and second figure are same. Third figure only is replaced. This is for case 2 and I am working here case 1. Third figure for case 1. How to do it? Now you redraw this figure such that BC is inclined at 45 degree to VP. That's all. So you can rotate like this or rotate other way around. This, like always we take ABC towards observer. So what I do is I will redraw this figure such that A, B, C, like this is B, this is C, this one is A, O and A. Now keep V here. Now join this. Okay, we see how exactly it works. This is dotted. Now project all these points. This is V. Now this is for the locus of V. This is V dash. And what about, sorry, this is V dash. A dash is here. A dash is here. Okay, this is V, this is A. Now C and B on ground. This is C dash, this is B dash. What more? A, B, C, B, that's all. Only 4 corners. Now join ABC first. A, B, C. Now join all corners of ABC with V. Now see what exactly is the visible surface. See, here I am definitely near to ABC, that is base surface. If I consider ABC as the base right now, that is also face in fact. Now ABC is visible. Yes, visible key surface method. And the boundary is visible. That's all. Now what about VC? VC is crossing the visible surface. Definitely this is invisible. So this is visible key surface method. Suppose if we take farthest point from you, farthest item from you, that is V. V is not visible, but actually it is visible. That is the utter confusion we are going to have in case of extreme, farthest point method. Best method is for all these cases, particularly pyramids, you always follow key surface method. So because of boundary, we can say V is also visible. As such, we say V is not visible, but it is actually visible. That's why, to avoid any confusion, always have key surface method. So this is how you can work out the tetrahedron problem. But for this also, we always include one particular point, that is axis, assuming that is limiting case of square, triangular pyramid. We always mention the axis. Wherever you miss, you also miss some points, marks, final marks. Here there is little scope for axis representation. Yes. Okay. Edge VA will be here only. Here there is little scope for axis. You keep this point and this point. To this point to this point, you have the value V, O. Now here also there is no scope for axis. Here we have drawn axis. Let me check all are over. Now let us avoid any confusion. First set of answers. Figure number 1, 2, 3. Second set 1, 2 and 3, 2. So this is actually the solution for case 1, case 2. Only third figure will change. So we will look for the same to be worked in computer. Let me take tetrahedron problem. A tetrahedron of sides 50 mm has a side on HP and a face containing the side on HP is inclined at 30 degree to HP. Draw the projections when the side on HP is 20 mm in front of VP. Okay, this is one of the questions. Now you can see the 3D view. So here yellow surface is BVC and the dark orange color, okay, brick red color is AVB, and one more is AVC is there backside, and base is as such ABC. Okay, I have to consider that as the base. That is also a face. You can consider that also for consideration. For all practical purposes, I am looking at this as a limiting case of triangle or pyramid. Now let me tell you how to work. Actually, you draw this first, then draw the median, because one side it rests on one of its sides. Definitely this side must be to the right side and perpendicular to start with. Then you take the locus of V. Okay. Now you have to get V dash here, as I explained earlier. A dash as center side equal to radius, that is 50 mm equal to radius. Draw. This is AV equal to 50 mm, that is equal to side. Then after getting this becomes the side. See here, for a 50 mm side you are getting 40.82, that is fixed. You cannot change. For a given value of side, this is fixed because the procedure is very specific. This is true length and this is apparent length. Because AV is parallel, definitely this becomes the true length. Suppose that the top view is in such a way that none of these slant edges are parallel, then you make that parallel and get this done. Okay, so that is how you find the, normally for this particular method, for a problem, this is side means this is definitely parallel. Okay, so that's how you get the height of the tetrahedron. Now majority of the time what people do is take height equal to 50 and draw. That is wrong. Okay, don't make this 50 and draw. This is the procedure you have to follow. Okay, now let me start with a specific problem. So here he says, after getting this top view, front view, fixing height using the side equal to radius, A dash as center, get V on the locus of or vertical projector of V. Then you have to consider this surface. Normally we consider this or this one. Okay, so I have done both here. Now first let me consider this. So usually we consider this as base, then we say take the slant face as the reference and give inclination to this. How to give this inclination? Then you move this in computer, you move this, and then from this point you draw 30 degree line and then rotate this particular figure so that this particular line coincide with this, so that you get the required line. See, here is the required line. Now if you project it, you will get this as the top view. So ABC is very small area, that is apparent length is very small because it is inclined to more than 60 degree. So more the angle, the lesser the apparent length. If it is 90 degree, you will get a line. Okay, so that's how it works. Now you see the completion of the top view is, so if you look from this direction, which is the farthest item from you, BC. BC is not visible. Then boundary completely dark. That's all. And then what about this line? This line is invisible surface, visible line. Okay, all are, see, the farthest item from you is this. Number of lines connecting to that are not visible, but all are boundary lines. Rest of the lines are dark. So that also you can work. So this is how you can see the invisible edge, and then BC is invisible item, that is not visible. These are all connecting that, but they are boundary, and this one is dark because rest of the lines other than this are dark. Next, just observe here, I have taken this 20 mm, yes, 20 mm distance. I have redrawn this, move and rotate. Here no question of rotate, here it just move. What you do is, you take this B as reference and move this and then rotate by 90 degree. Okay, rotate by, not with any angle. rotate by 90 degrees so that you get this line on 20 degree, 20 mm line. So while you move this such a way that C is touching this line. Then rotate in this direction. Okay. So clockwise. Okay. Then you will get this V. Till it touches, you keep it. Then you project it, you will get this one. As I told you earlier, V is within this. Now, if you look from this direction, ABC is away from you. That is the base under consideration is ABC now. That is also a phase, but let us consider that as the base in this case for reference. It is away from the observer, base is not visible, but all edges are visible. A, B, C is a typical case where all edges are visible. None of the lines are invisible here. Okay, but surface ABC is not visible. Okay, now how to complete? See, the ABC is not visible. Okay, but boundary line is completely dark. So that gives you the edges ABC only dark. That doesn't mean that you can see the surface, but invisible surface. Edges are visible, but surface is invisible because it's away from you. Then whatever the number of lines, invisible surface, visible lines. So naturally these are all visible lines. So this is how you can complete this. Now as I told you earlier, here there is no much scope for axis, but there is a little scope for axis. From this point to this point you have to keep the, you trim this, cut this portion whenever you have a line and replace that with the axis representation. So this is how you can complete the problem on tetrahedron. Now suppose that you have the base itself you consider as face. Yeah, that is also a face. If you 30 degree, do one thing, you move and then rotate with respect to BC as center, rotate with A, but such that it gets you 30 degree line. Then you get the top view, yes, this, okay, this is not visible, it is ulta. Whatever the answer you get, it becomes ulta. Because of the characteristic feature of tetrahedron is all sides are equal, all edges are equal, all slant edges are equal. Okay. No, there is no slanted business here. If you consider this as the limiting case of triangular pyramid, then you can say it's slanted. Otherwise, all sides. That's why it's given only one dimension. Okay. Now, you get the corresponding figure. See, if you after giving this, inclination to this surface, you get this. Okay, sorry, this one. If you consider this, this is the solution. Next comes this. I have considered this only for 30 degree line. Okay, with just the first one, and then worked out this. See here, the angle is taken for this only. Yes, this phase VBC is only taken, and then corresponding top view is rotated such that it is in BC is inclined at 45 degrees. This is what. Next comes the final front view. How to complete the, in this direction? If you look again, ABC is not visible, right? Yeah, in this case ABC is not visible. What you do is you keep this ABC, the first step you avoid. Otherwise farthest point from you is C. Okay, again that is confusing because C is on the ground that is connecting number of lines. Best method is the invisible surface, visible surface, key surface method. Now if you look from this direction, ABC is not visible. Fine. You drop that step. Second step is boundary lines completely dark. Yes, you keep the boundary lines dark. Then invisible surface is ABC. Out of ABC, AC is not visible. Okay, because other two are boundary. Then this surface is invisible. Definitely this is crossing line. Okay, or invisible surface, visible line. So this is how you complete the solution for the tetrahedron. Okay. Now we will also work out on problem on cube. Okay, that we will take it in the coming session.